Hello everyone. In U&ICP, we're discussing about the law of radiation. Okay, so various radiation effect we discuss and also discuss the laws for the radiation. So now we're discussing about the radiation pyrometer. So radiation pyrometer is generally or depend upon the Stephen Boltzmann's law. Okay, so heat transfer area is directly proportional to heat transfer. Okay, is directly proportional to the area of heat transfer and the product of temperature, which range of 4 power of 4. So which is given by sigma b, okay, equal to phi b equal to sigma a t raised to 4. Now what are the principle is used in radiation pyrometers? So according to the Stephen Boltzmann law, intensity of radiant energy is emitted by body at a hot target varies at a fourth power of its absolute temperature. So the definition is said that the intensity of radiant energy, okay, that is phi b, is emitted by hot temperature varies the fourth power of its absolute temperature. In a radiation pyrometer, the absolute visible and infrared energy is focused on radiation detector, which is converted into the proportional electric signal that indicates the target temperatures. रेडिएशन पायरोमीटर के अंदर जो एब्सोल्यूट टेम्परेचर है, विजिबल और इंफ्रारेड एनर्जी है, विच इज़ फोकस ऑन द रेडिएटर डिटेक्टर, विच इज़ कन्वर्ट इनटू द इलेक्ट्रिकल सिग्नल एंड टारगेट टेम्परेचर. जो भी एनर्जी आ रही है, ठीक है, रेडिएशन के थ्रू, तो उस एनर्जी को क्या करता है, उसको रिसीव करता है और उसी एनर्जी को इंफ्रारेड और इलेक्ट्रोमैग्नेटिक वेव्स में क्या करता है, कन्वर्ट करता है. एंड वो जो इंडिकेट करता है वो क्या करता है, टारगेट टेम्परेचर. सो कंस्ट्रक्शन वी कैन सी इन द फिगर इज दैट लाइक अ रेडिएशन पायरोमीटर. सो the sun rays, or we can say that hot bodies, it directly goes on the lens of the radiation pyrometer. So this one is a diagram which should be said that the total energy is emitted on the thermopile or a thermocouple, okay, which is directly connected with a indicator. So thermopile or a thermocouple, we can see that the thermocouple is measuring point which can measure the temperature. So it is directly goes on the indicator. So the figure is so that the construction of radiation pyrometer that consists of a lens, diaphragm, okay, उस consistence क्या करता है, that is a lens और diagram, radiation receiving element, जो भी रेडिएशन आ रहा है उसे क्या करना चाहिए, रिसीव करना, लाइक अ थर्मोकपल, साइटनिंग हॉल एंड रिकॉर्डर और इंडिकेटर. साइटिंग हॉल और रिकॉर्डर और इंडिकेटर इट शुड बी रिक्वायर्ड. एंड द डायग्राम पोजिशंस कैन बी ऑल्सो एडजस्टेबल फॉर कैलिब्रेशन. कैलिब्रेशन के लिए हम जो डायग्राम है उसकी पोजीशन को हम चेंज कर सकते हैं बेस्ड ऑन द एप्लीकेशन. नाउ द टारगेट साइज. सो व्हाट इज अ टारगेट साइज? Target size is the minimum at a focal length of the objective, but it is increased with a distance from the lens. Target size is the minimum focal length. क्या है टारगेट साइज? जहाँ से सन रेज आ रहा है लेंस के ऊपर, वो डिस्टेंस से लेके वो जो सन रेज का जो फोकस हो रहा है, ठीक है, फोकल जहाँ पे फोकस हो रहा है, सो वो लेंथ, ओके। सो विच इज़ इंक्रीज विथ डिस्टेंस फ्रॉम द लेंस। अगर हम लेंस का डिस्टेंस बढ़ाएंगे, ठीक है, फोकस पॉइंट का, तो वो भी बढ़ेगा, इंक्रीज होगा। द टारगेट क्रॉस सेक्शंस कैन वेरी फ्रॉम circular to rectangular. It is the cross section is if we increase the distance, આપણે ડિસ્ટન્સ વધારીશું તો શું થશે કે જે ફિગરમાં બતાવે એ પ્રમાણે अगर हम क्या करेंगे, डिस्टेंस को हम बढ़ाएंगे, तो पहले का शेप क्या था, पहले का शेप ये था ट्रायंगल, ठीक है, जहाँ से हम क्या कर रहे हैं, जहाँ से ये जो सन रेज आ रहा है, तो ये जो फिगर है वो क्या है, ट्रायंगल, ओके। अगर हम यही डिस्टेंस को बढ़ाएंगे, जैसे कि ये जो थर्मोकपल है उसको हम और पीछे ले जाए, दैट मीन्स डिस्टेंस बढ़ गया, तो यहाँ से ये रेडिएशन इस तरह से होगा, ठीक है, इस तरह से। मान लीजिए कि ये पॉइंट अगर हमारा यहाँ है, तो यहाँ है तो उसे उसका जो ट्रायंगल से रेक्टेंगुलर में कैसे बदल सकता है, जैसे कि ये सन रेज यहाँ से इतना ऐसा जाएगा और यहाँ से ऐसे ऐसे, तो ये पूरा शेप कैसे बनता जाएगा, एज अ रेक्टेंगुलर सेक्शन में। एंड इवन स्लॉट शेप डिपेंडिंग ऑन apparatus इन द हाउसिंग डिज़ाइन ऑल्सो એ કોના પર ડિપેન્ડ કરે છે, ધ ડિઝાઇન ઓફ ધ housing. And the telescopic eyes piece can be magnified the radiant energy such as that the smaller target at a greater distance can be viewed. Target of 1.6 mm diameter are feasible with proper design. The target जो किया है वो क्या है, 1.6 mm. द फिजिकल शेप, उसका कंस्ट्रक्शन के अंदर फिजिकल शेप ऑफ द पायरोमीटर लाइक दैट द ऑप्टिकल सिस्टम एंड इट्स माउंटिंग कंट्रोल द साइटिंग पाथ वाइट इज मटेरियल डिटरमाइंस द ऑप्टिकल प्रॉपर्टीज एंड द ग्लास डज नॉट ट्रांसमिट वेल बियॉन्ड 2.5 माइक्रोन। ग्लास की जो साइज है 2.5 माइक्रोन। इट इज़ सुटेबल ओनली फॉर हाई टेम्परेचर, इट इज़ suitable for high temperature ranges where plenty of outputs is available. Other materials are quartz up to 4 micron, CF2 up to 10 microns, laser use material like a greater than 10 microns, which is can use. Windows and filters. Okay, windows and filters. Alter transmutation properties. A filter must be purposely placed in front of detector to cut off unwanted wavelength. Windows and filters, which is alter transmission properties. So exactly must be purposely placed in the front of detector to cut off the unwanted wavelength where it is used. Different types of radiation pyrometer design are used, જેમ કે broadband total radiation pyrometer, single band pass pyrometer, and third is a ratio or two color. Third one is ratio or two pass band pass pyrometers, two color pyrometer. Radiation receiving element. So which types of radiation receiving elements? Radiation receiving elements is required. So thermopile is one of the type. Is that thermopile consists of a number of thermocouples connected in series with their measuring junction flattened and blackened are shown in figure. થર્મોપાઇલ એ શું છે? થર્મોપાઇલ એ છે કે થર્મોપાઇલની અંદર કે જે જુદા જુદા પ્રકારના જે થર્મોકપલ છે એને સિરીઝમાં ગોઠવેલા હોય છે. સો દેટ શુડ બી કનેક્ટેડ ઇન સિરીઝ વિથ ધેર મેઝરિંગ જંક્શન. ધ मेजरिंग जंक्शन इज ऑल्सो इंडिकेटिंग दैट. तो वो क्या होता है, देयर इज अ टू टाइप्स, दैट इज 2.33 that is construction is like that કે જે બે જગ્યા પર thermocouple in the four direction thermocouple are connected in series, then 2 points are measuring the reference junction of each thermocouple is located at the outer ring where the individual thermocouples are connected. Second is vacuum thermocouple. Vacuum thermocouple is also seen in figure where measuring junction which is platinum foil का होता है और this one is transparent glass होता है जो easily देख सके, and this one is reference junction. So this figure shows that the vacuum thermocouple that consists of a evacuated glass envelope in which a single thermocouple along with blackened platinum foil is placed. બરાબર, જે અહીંયા પ્લેટિનમ ફોઇલ મૂકવામાં આવે છે મેઝરિંગ જંક્શન તરીકે. The reference junction is located in the base of the unit, and it is prevent any loss of heat from the measuring junction by the conduction and convection. Okay, so exactly the main use of the glass is that to prevent any heat loss from the process like a conduction and convection. Okay, third one is bolometer. Bolometer is a resistance thermometer usually in strip form made up from the nickel and about the 10 ohm resistance, it having a near up to 10 ohm resistance, and this one is with a gold black platinum back or increase in absorptivity. अगर हम उसके अंदर हम गोल्ड अथवा तो प्लेटिनम का कोट करेंगे तो वो उसकी जो एब्सॉर्प्टिविटी है वो क्या होगी, इंक्रीज हो जाएंगी. D is photomultiplier tubes and photon detector. If the radiant energy falls into semi-crystalline material such as the silicon, lead sulfide, etc. જ્યારે આપણે રેડિયન્ટ એનર્જીને માટે આપણે જે યુઝ કરીએ છીએ એ શું હોય કે એ જે હોય છે એ કેવા હોય મટીરિયલ લાઈક સિલિકોન મટીરિયલ હોય અથવા તો lead sulfide હોય ત્યારે the electrical charges get released that give electrical output in proportion to intensity of radiant energy. તો એ બધા જે પોઈન્ટ્સ હશે એ શું કરશે કે જ્યારે રેડિયન્ટ એનર્જી છે એને કયા ફોર્મમાં કન્વર્ટ કરીને આપશે, ઇન ધ ફોર્મ ઓફ ઇલેક્ટ્રિકલ ચેન્જીસ. ઓકે, जो एनर्जी है रेडियंट एनर्जी that falls into the electric energy. It gives fast speed of response that permits measuring temperature of small object moving at a high speed. The response time should be very high. Okay, where relatively energy output is very small, and so these types of elements are very sensitive to wavelength. Now, working. Radiation at all possible wavelength from a hot body are focused by the lens. શું કરવામાં આવે છે કે હોટ બોડીમાંથી જેટલા પણ રેઝ આવતા હોય છે એને લેન્સ દ્વારા ફોકસ કરવામાં આવે ઓન ધ રેડિયેશન રિસીવિંગ એલિમેન્ટ, અને કોની સાથે કનેક્ટેડ હોય, જે રેડિયેશન એલિમેન્ટ છે બરાબર રિસીવિંગ એલિમેન્ટ એની સાથે કનેક્ટ કરેલું હોય. When a thermopile or a vacuum thermocouple is used as a radiation receiving element, જ્યારે આ ટાઈપનું કોઈ પણ આપણે મટીરિયલ યુઝ કરીએ ત્યારે મતલબ ટાઈપ્સનું થર્મોકપલ યુઝ કરીએ ત્યારે the radiant energy from the target is focused on black net measuring junction, and due to the absorption of radiant energy the measuring junction temperature rises. જે ટેમ્પરેચર શું થાય, રેસ થાય છે. શું કામ કે એક ટાઈમ પર આપણે શું કરીએ છીએ એને ફોકસ કરીએ છીએ, and due to the absorption of radiant energy measuring junction temperature rises. And according to the Seebeck effect, EMF is electromotive forces developed between the output lead and which is proportional to the temperature difference between measuring and reference junction. હવે જે એબ્ઝોર્બ કરે છે, બરાબર, જે સરફેસ, તો એનાથી શું થશે, હીટ પ્રોડ્યુસ થશે, એટલે કે ટેમ્પરેચર ડિફરન્સ ક્રિએટ થશે, બરાબર. ક્યાં કોની વચ્ચે, જે ટેમ્પરેચર આપણે માપીએ છીએ, એટલે કે રેફરન્સ ટેમ્પરેચર અને આઉટપુટ ટેમ્પરેચર, બરાબર. When this element is connected with uh, millivoltmeter type instrument, the electromotive force developed can be calibrated in terms of targeted temperature, and if bolometer element is used, then the resistance of foil charge with the change in the temperature. So the bolometer can be calibrated in terms of target temperature with Wheatstone bridge circuit. Okay, so these are the working of radiation pyrometers.